Good afternoon and welcome to NASA's Kennedy Space Center. We're here today in preparation for a launch tomorrow morning of SpaceX's 7th Commercial Resupply Services mission to the International Space Station. It's set to launch at 10:21 a.m. Eastern Time tomorrow, and our launch coverage will begin at 9 a.m. Eastern Time tomorrow. This mission is carrying more than 4,000 pounds of supplies and payloads, including critical materials to support more than 30 student experiments, and more than 35 ongoing investigations for expeditions 44 and 45. Among the payloads on this mission are the student experiments and the first of 2 international docking adapters that will enable commercial crew vehicles to dock to the International Space Station. We'll be discussing these things today in our briefing. The station's role as a U.S. national laboratory, managed and supported by the Center for the Advancement of Science and Space, or CASIS, makes possible numerous investigations, including more than the 30 student experiments. Student investigations from the Student Spaceflight Experiments Program and the National Design Challenge will be flown on Dragon and returned at the end of its mission. Using NanoRacks experiment modules, these studies will span a wide array of scientific disciplines. Some of the science objectives include testing a new hypothesis to simulate pollination in microgravity for food crops, investigating a new type of plastic to block radiation from the sun to protect future astronauts on a journey to Mars, and analyzing the performance of a new energy source called solar liquid power, which combines nanotechnology and electrochemistry in the form of a paint-like coating. CASIS has developed a science, technology, engineering, and mathematics education initiative entitled the National Design Challenge, intended to further CASIS's efforts in encouraging students to become more excited about science. 2 Houston schools and 3 Denver area schools will be sending 7 total investigations to the ISS National Lab. Here to talk with us today about their investigation are Heidi Smith and John Weiler from Bell Middle School in Golden, Colorado. So Heidi and John, will you tell us a little bit about your investigation?
Sure. So our investigation is to see if red wiggler worms can compost in a microgravity environment. So we chose red wiggler worms because they are actually a very hardy worm, and they are used for gardening, and they compost very, very well. So we wanted to see if they can compost so we can have gardens and crops on the ISS for astronauts to eat.
Great. And what was your role?
I was in the biology team. I was one of the leaders.
Okay.
I'm in the engineering team, and we were responsible for creating this box and programming it. Using the NESI microcontroller and 3 sensors, we would be recording what happens to the worms when they're up in space. My job was to oversee all of this, and we used a camera, a moisture sensor, and a temperature sensor. These 3 sensors would record how the worms were responding to the microgravity environment. The camera would take pictures. A picture is worth 1,000 words. And the moisture sensor would record the moisture in the box as the experiment progressed. The temperature sensor would be responsible for seeing how the worms emerged from cold stone reanimated, as Heidi will talk about later.
Great. Thank you. So how long have you been working on this experiment?
We've actually been working on this all year. I got an email at the beginning of August saying that we are actually going to do this experiment. And so they were just, my teachers, Ms. Atzmiller and Mr. Swift, they emailed me and they said, we are going to do this experiment to see if red wiggler worms can compost in microgravity. So we started this entire school year, and it's awesome that it's so close to being launched.
Yes, for me, this project started about a year ago in July. We went to a local museum and met with some CASIS officials and got all the parts, the nano lab, which our experiment in the box will be going in, and that was the time we started our experiment. We had all school year to work on this in our separate teams, and this at the end of school we had a final design prepped. This box, the worms would go in it, and the compost, and this was all being sent down here to NASA where they would load it onto the shuttle. So here we are.
So how many worms go into the investigation, and how do you expect it to proceed?
So there will be 11 worms that will be going into the 3D printed box. And so I think that this experiment will go very well. Personally, I hope it will, just because we have spent a year on it, and these worms, through some of the experiments, were very stubborn. They did not like it, but now they push through, so I think it will go great.
Great.
Yeah, with all the effort that we have put into this project, and with all the ideas we've come up with, and all the ideas we've shot down, and all the changes we've made, I really hope this will work. And I personally have high expectations for it, because we've planned for a lot, and I think it'll work.
Hopefully.
And so when you say we, it was more than just the two of you, presumably.
It was the 8th grade iSTEM class at Bell, 60 of us, all split up into different groups, all working on a separate problem. And together we designed and created and completed our experiment.
So who are we looking at now?
This is the software team. This is my group. We got Jake,
Okay.
Linus, me, and Hans. We were responsible for programming the NESI microcontroller, which would take the readings from the sensors every 6 hours, 3 times, at 1 minute intervals, and record exactly what's happening on board. At the end of the mission, we will retrieve the SD card from the NESI microcontroller, and we will see what's happened on our experiment.
And I think this looks like must be the whole team.
Yes, that is all of the teams in this experiment, all of them. It's
all 60 of us. We've labored for countless hours to get this up and running, but it was extremely fun.
And so what were the different teams?
So there was mechanical, hardware, software, communications, art, biology, structural.
And that was it.
Yeah, that was it.
Okay. And we have one more picture. What's this one?
This is the biology team. So there was a lot of people in the biology team, because it was between kind of 3 divided groups. And I believe it was 24, like a whole class in this particular group, but it was very fun working with all of them.
Great. So we'll take some questions from the group. We'll also take some questions if you're following along online on Twitter. You can tweet Ask NASA, use the hashtag AskNASA, and we'll take questions from those in the room and online. Please raise your hand and let a microphone come to you. Introduce yourself and to whom you're directing your question. Question here.
Jim Siegel, I'm with Celebration News and Spaceflight Insider. Congratulations on this wonderful experiment and on the ability of you to convince NASA to put this in CASIS. I wasn't quite sure what happens to the worms now. They're going up. They're going to be part of this experiment. Is this package coming back down, or are they staying up there, or what?
At the end of the mission, the package will be coming back down, and we will be recovering it, and it will be sent to us about 2 weeks after the mission ends. So around the middle of August, late August, we'll be receiving the package again. We'll be examining the physical evidence, the compost, the worms in the box to see what happened, but we'll also be using the digital evidence on board the SD card to see what's happened during. The SD card is integrated, and it will be inside the box on the NESI microcontroller.
Hi, Val Phillips, 0G News. I'm kind of curious as to whether the original concept, the idea, was something that the students came up with, or whether the idea was from the teachers to a certain extent, but you're the ones who came up with the solution, which you're now putting up.
Yes. So our teacher, they actually proposed this idea. And so they actually got with CASIS, they got this chance. So then they recruited all of the 8th grade ISTEM. So then we all got to work on this experiment together.
Hi, Brenda from Space Trepreneurs, all the way from Perth, Western Australia, part of the NASA social team. Were there any big failures that you had that you could share with us? They're not failures, they're more like lessons.
Yeah, absolutely. One of our main failures involved the whole team, the mechanical team. In the beginning, we thought we were going to have a door that would separate the worms from the compost. So on the way up and in pre-flight, they would not compost. The way we fixed that is we used cold stow, where the worms are frozen, essentially, so that they wouldn't compost. But to begin with, we thought we would have a servo and a little 3D printed door that would open. Turns out that didn't work very well, and the worms would get stuck in the servo and
wrap around it
and essentially butchered. So we decided in the end that probably wouldn't be best. And when we kind of looked at our box at the end, we found that the simplest ideas usually worked the best. And this simple box, it's really just a box with 2 separate compartments. That's all it is. And that ends up working the best instead of some super complicated thing.
Like John said, we had to use cold stow. My team probably did about like 25, something like that. I don't even know how many experiments, and all of the worms ended up dying. So we had to get a new batch of worms so we could retest, and eventually it worked out just the way we wanted it to. So that was pretty nice.
And that was testing what temperature to put them at in cold stow?
4 degrees Celsius, yes.
Okay. I think we have another question back there.
Peter Wright with NASA Social. 2 questions. The cold stow thing, can you explain exactly what that does? And then the second question, if this experiment is a success and they do compost really well, what does that mean for the future?
So what cold stow is we want these worms to go into like hibernation just so that they won't compost, because if they do end up composting, then it's going to ruin the data that we want to see. So they have to be going into hibernation, and then once they get up to the ISS, they'll go back up to regular temperature that is on the ISS. So then they can move around, and once they go back, we are planning to have them in cold stow again, just so they can go back into hibernation, just so the flight down isn't rough on them.
And so what the main idea of this mission is to figure out if we are going to go to Mars or any planet even further, to galaxy far, far away, we need to be able to sustain our astronauts in flight. Turns out we send down nearly 100 pounds of trash for each astronaut, and that is insanely wasteful. So if we can figure out how to compost worms, how we can use worms to compost, and that way we can plant food and get it to grow faster, we can greatly reduce the amount of money and resources it takes to get to different places. And that means we also won't have to take lots of frozen, freeze-dried food on missions with us if we can just grow it.
And what's in the compost?
So what is in the compost is there is cotton balls, paper muffin cups, there's also eggshells, coffee grounds, and newspaper. So 5 different things in the compost.
Ken, you had a question?
Yeah, Ken Kramer from Universe Today and the Northeast Astronomy Forum. I wonder, 2 questions. One is, will the astronauts look in flight at the data, at the worms at all, and report any observations? And the second question is, talk a little bit about more how you selected this type of worm and exact worms that are going into space. Was there a worm competition or something like that? Thank you.
You can go.
So first of all, we what was the question again? Oh yeah.
Make any observations?
Yeah. So we are not planning on having astronaut time. Our box is going to run completely by itself, and there will be no need to have anybody to touch it after it has been plugged into the rack. And the only 2 times anybody will touch it is when it's getting plugged in and when it's getting taken off. But other than that, it's completely running by itself, and everything will happen by itself.
So with choosing the red wiggler worms, they are a very sturdy worm, and so they do compost very well. There was no competition to choose these worms, but our teachers did see this worm, and it was very, very sturdy, and they compost very well. So we thought it was a great choice for worms.
And you'll get the data back after the mission is complete, not during it, right?
Yes.
Right. It'd be very difficult to get it back during the mission.
Hi, congratulations first. I was wondering, what's the total mission timeline, and do you know when particularly the experiment will be delivered back to Earth yet?
So the experiment will run for 21 days, and on August 5th, they should send it back down. So it should take about 2 weeks before we actually get to see it and see the results. So right when school actually starts for high school, but hopefully it will run like we would like it to. So yeah.
Some questions from online?
Yeah, we have a couple questions from social media. Ian asks on Twitter, how old are the worms?
They're mature.
They're mature for their age.
They're in their mid-life span. They're not young and they're not old. They're average and they're not all the same age, but they are. They're in that midlife.
Middle-aged worms.
Yeah.
Okay, gotcha. And then Rome asks, will anything be shared online? Will pictures be shared online? Will the public be able to see the updates?
Absolutely. Bell has a Twitter, and we also have an Instagram, and all these pictures will be online. We will probably have another video going out. We've had videos during this made by our communications team. They've been posted on YouTube, and we'll definitely have another one when the data comes back on what's happened during the mission.
More questions? Val?
Hi, Val Phillips, Zero G News. What I'd like to hear is how has this inspired yourselves personally in respect of prior to becoming involved with your in respect of how you view NASA, space, and what would your plans be in the future in relation to how this has all been panning out?
So before we actually started this experiment, I was kind of into science, I loved it, but I wasn't my heart set on going into something with science. But after I started this and really got into it, I really loved the idea of STEM. And so hopefully I go into a STEM career when I get older. I actually want to go into biomedical engineering. Before I wanted to be a chef, which are completely different, but now I really, really want to go into that field.
So I've always been interested in space ever since I was born. Loved the idea of rockets and everything. And by doing this project, I've just gotten closer to it, and I really can't wait to go into a career that involves something that has to do with space. Not sure yet, but it's definitely going to have something to do with space.
So what's the response you get when you tell people you're flying an investigation to the space station?
Well, they're pretty much just like anyone. They're their jaw drops, their eyes get wide. It's amazing that teenagers are actually sending a project up to the ISS, and so it's amazing to see their reaction just because they probably never have gotten to do it at such a young age, but since we are, there's oh, tell us how it goes, what are you guys doing, blah, blah, blah. So it's awesome just to see the reaction that we get.
Whenever I tell somebody, they're always astounded at how we could do this when we were so young. And they're always really amazed at how dedicated we are, which that's pretty true. And they also, mostly, it's just a lot of questions and a lot of congratulations on how well we've been doing and around that.
So would you have any advice for next year's 8th graders?
Well, have simple experiments. Don't try to go overboard with something that's too crazy, going over their heads, but simple works. Hard probably won't. Just anything simple, it could go up to the ISS someday.
Yeah, work hard, you'll probably achieve your goals. And if you're faced with a problem and it's not working, try to dumb it down a little, because that'll probably solve the problem and you'll still be able to do what you're trying to do. But overall, just try hard and you'll achieve your dreams.
Any last questions? Okay, great. Thank you guys very much. Did a great job. Now we're going to take a look at a video about NASA's Commercial Crew Program as we get ready for our next panelists.
Hi, I'm NASA astronaut Mike Fink, and I'm very excited about our country's vision for the 21st century space program. First, we have our beautiful International Space Station. And aboard this orbiting laboratory, we make new scientific discoveries every day. And working with our industry partners, we're developing new ways to transport crews, astronauts, from here in America. And having launched from different launch pads all over this planet to the beautiful International Space Station, I'm very excited that through the Commercial Crew Program that we are returning launch capability back to the United States, launching from Florida's Space Coast to the space station and returning back to the United States. And that allows us at NASA to focus on beyond low Earth orbit to the Moon, an asteroid, and even Mars. And we have a new big rocket, the SLS, Space Launch System, paired with the multi-purpose crew vehicle called Orion on top, and that will allow us to explore our solar system like never before. How cool is that?
So the first of 2 international docking adapters for the space station will be delivered in Dragon's unpressurized trunk. The adapters will enable space station docking of commercial crew spacecraft, including the Boeing CST-100 and the Crew Dragon from SpaceX. Here to talk about the preparations that NASA is making for these changes are Lisa Colorado, the Associate Program Manager for the Commercial Crew Program at NASA's Kennedy Space Center, and Bill Dowdell, Technical Director for Ground Processing for the International Space Station Program here at NASA's Kennedy Space Center. Later, we'll have Boeing's Chris Ferguson and SpaceX's Hans Koenigsmann join us to talk about their commercial crew spacecraft. So Lisa is the Associate Manager of the Commercial Crew Program, which is leading NASA's efforts to develop the next United States crew transportation and rescue service capabilities to and from the International Space Station and other low Earth orbit destinations. Lisa's been an integral part of the Commercial Crew Program leadership team since June 2012 and helps direct the budgeting, contracting, safety, and technical areas of the program. Bill Dowdell serves as the Technical Director for ISS Ground Processing. He ensures that requirements are met for the critical spares that we fly to the International Space Station, and also plays a role in hosting the ground processing for the science being performed on the ISS. Bill's been with NASA for 26 years and at KSC for more than 31 years and has worked on both the Space Shuttle and International Space Station programs. So Lisa, Bill, can you talk to us a little bit about the advancements we're making toward the Commercial Crew Program, the work that's been done and on the International Space Station, and what we need to do to continue to be ready for these commercial crew spacecraft?
Okay, so before we start, I would like to say something, and that is how impressive it was to sit here and listen to those 2 young folks talk about getting something ready to fly on the ISS. And something that really struck me is that they said simpler is better. That's very true, and that is exactly why we developed the International Docking Adapter the way we did. Mr. Suffredini and others in NASA called for us to take a look at some of the prior systems we had in development and ask the question, is there something else we can do that's simpler, fewer parts, that we're going to be able to perhaps hand off to industry to be able to build like copies of. And so, again, that really resonated with me, that those guys also discovered that basic tenet of engineering, that simple is a good thing. Let's see, to talk a little bit about the mission. First of all, glad to be here. Looking forward to all this hardware that's going to space, both the science and the hardware itself. We mentioned the International Docking Adapter that's flying. We got an oxygen tank that's flying as part of the nitrogen oxygen recharge system. First time we'll get this oxygen tank on orbit. That system is a reusable one. So that's a good deal for both for NASA and the American taxpayer, because we can refly them after we take them up and replenish the supplies on orbit. Something else that's flying this time that struck me that I thought I'd mention is the Microsoft HoloLens is flying. And that's a new tool that we're going to give to the astronauts to use. It's basically something they wear while they're doing a task, and it enables both the ground controllers and the flight crew to communicate better, and the ground controllers are better able to see what the flight guys are doing. And it also has the ability to project holograms and a lot of other capabilities. I haven't read up completely on it.
We got a great briefing about it yesterday, too.
Okay, well, you guys already know that. But anyway, it just struck me that here we are, we've got something that's capable of projecting holograms as the astronaut is using it. And I couldn't help but think, if you guys have ever tried to put something together that came in a box at home, if you had somebody that could see what you were doing and be able to project while you were doing it, how that would be handy. So I'm expecting we'll find good use for that. Let's see, for the International Docking Adapter, we've got a fair amount of work ahead of us to reconfigure Space Station to be ready for that. I'm going to refer to my cheat sheet here. There's a lot of planning going on right now to relocate the permanent multipurpose module, to relocate a pressurized mating adapter, to install the International Docking Adapter. First thing we'll do is we'll move the permanent multipurpose module. We'll move it from the Node 1 nadir to the Node 3 forward. As a result of that, we'll free up a berthing port. After that, we'll be able to take the IDA number 1 and install it on pressurized mating adapter number 2, and that's on Node 2 forward. Then we'll take pressurized mating adapter number 3 from Node 3, and we'll move that over to Node 2 zenith. So Node 2 will effectively become the docking port that has 2 docking adapters on it as we go through the sequence of events. And then last is we put the IDA 2 on that PMA 3. And so that work is being planned, both the EVAs for it and the work that the ground controllers have to do. It's going to complete over the next months. I think by the time we get into the end of the calendar year, we expect all that to be in place. And I think that's kind of a good summary of where we are with the IDA and the major things that are going up on this mission.
Okay. And I also wanted to congratulate Heidi and John, and just, it was very inspirational to us. I know that sometimes the students say that we do inspirational work that motivates students, but honestly, I think it comes back like tenfold when we hear something like we just heard earlier today, so thank you. And I also want to say, you know, there were 2 things that they both touched on too that are very relevant to what we are doing here at Commercial Crew, or what we're striving and will be doing. They talked about the precious time for crew on station. So every minute of time on station is like gold to us, right? So it's such a unique and valuable asset that we have, and the science that we do up there is really what the Commercial Crew program is all about. So we are trying to get our crew to station, and in our case, once we have this capability, we will be increasing the crew size, which equates to more valuable time to do the science and the research on board, which is exactly what it's for. So they already learned that lesson on a small scale. And the other thing they mentioned was, you know, the value, or the wasteful, as John put it, what a waste it is to bring the material back. So in Commercial Crew's case, we are going to actually have, the vehicles are going to have increased capability, so cargo capability to upload and download, down mass. So they already learned that lesson. So on a small scale, some of what you guys are doing is exactly the purpose of what we're trying to accomplish with our program. What's going on right now with the IDA and the hardware, to us, that is just like a huge boost to us. We've been working for a couple of years, and anytime that the hardware comes, so delivery of a docking adapter, and recently we had SpaceX did their pad abort test, and some of the work going on at the pad over on the Air Force side to build a crew access tower and all that. Those are all just the building blocks and the steps that we're taking to get where we're going, and it's very much a boost, and we're really super excited about it. We're going to get there soon, and we're looking forward to it.
Great, so we'll take some questions. Also, we'll continue taking questions from those online. If you want to send a question to us, use the hashtag AskNASA. So questions about Commercial Crew and the International Space Station program, this mission. Ken?
Hi, Ken Kramer for Universe Today Northeast Astronomy Forum. You touched on the 7th crew member. I wonder if you could amplify a little bit about additional cargo and experiments that'll have to be brought up for that crew member, and how that will really augment the science that's done on the station when you have this 7th person. Thank you.
Yes, so we have requirements to have 4 crew on CST 100 and the SpaceX Crew Dragon. That will increase the crew capability up to its max on station to 7 total. That's 1 more than we've had. And so there's a lot of time that the crew is working on, other things. They have to do a lot of things to maintain the station, and there's just a whole series of work. But the more crew time you have up there, like I said, is more valuable, that you can do more science and research. So that's what we're really excited about. So I think, our capability that we're adding is really good for all of us as a community. And then you had another part of the question. I'm not sure I captured the second part. Well, the payloads or the cargo they had to.
You're going to have to bring up more cargo to support the 7th person for science experiments. So how will that weigh?
Yeah, it's a good question. I don't know. It's a big difference between 6 and 7 to support an extra crew member. The real value in our systems is additional cargo capability that we can take up and down to do more science and resupply and that kind of thing. So I think the amount of cargo that is required for the 7th crew is, I don't know what the exact number, but it's not huge.
Okay, James.
Hi, James Dane, Florida Today. Lisa, the funding for next year that Congress has approved or so far indicated it's going to approve is considerably below what you had requested. So can you tell us how that might affect your milestones coming up near term and ultimately your timeline for actually launching a crew?
Yeah, so I knew there'd be a budget question, right? Always difficult. Obviously, the best way to avoid unnecessary schedule delays and costly reworking and the changes that come with changing a schedule and a budget is always difficult. We're still hopeful. We don't have the number. We don't have the exact number yet. So we as always we will adjust to whatever the people at higher B's tell us what we need to live within. But the best way for us to stay on track and meet our goal to have the capability by 2017 is going to obviously depend on the budget. Mm-hmm.
Hi, Casey Ayers with NASA Social. I was wondering if you could speak about any of the key differences, strengths or weaknesses behind Crew Dragon versus CST 100. Is one platform more suited to certain tasks than the other, or is it essentially a competition to see which model proves to be most effective for ISS?
I don't know that I'm the best one to talk about the differences between the capabilities technically. I would just say they're both very unique. They both have benefits that each one has, and they're different from each other, obviously. But the key is that they both have to meet our basic fundamental requirements for safety and performance, and to keep our crew safe. That's the most important thing. They may be able to, when they're up here, they may be able to talk a little bit more about the capabilities that they have.
Jim?
Jim Siegel, I'm with Celebration News and Spaceflight Insider. You mentioned a little bit about the goal of beginning the commercial program and getting people up into the ISS by 2017. Correct. So could you talk a little bit about what happens after that? What are some of the other milestones or timelines? And is this kind of an indefinite thing that's going to go out or just until the end of the space station program, or what?
Sure. So our goal is to have the capability by 2017. You're correct. We right now have plans for each Boeing and SpaceX to have a minimum of 2 missions that we want to buy that take our crew to station and back. So that's 2 apiece. We could have the capability to have up to 6 per provider per company, and we will decide that later. But eventually, we're going to have 2 missions a year. This is our current plan, 2 missions a year to station and back. And currently, the station is planned to extend until 2024. And so we will be operating up until 2024. That's the plan as of now.
Any other questions for Lisa or for Bill? Okay, thank you. And so now we're going to take a look at some of the work that Boeing has been doing for its Commercial Crew Program and bring up Chris Ferguson.
The first new crew access tower to be built at Cape Canaveral Air Force Station since the 1960s is taking shape, as Boeing and United Launch Alliance work toward flights of the CST-100 spacecraft in 2017.
This is an extremely exciting time. It's great to be doing the construction after so many years of designing, and the excitement is incredible in terms of we're putting American astronauts back on American rockets through the Commercial Crew Program, and we're bringing Atlas back to its heritage from the Atlas Mercury program.
Workers are assembling the tiers that will be stacked atop each other at Space Launch Complex 41 this year. It will take 7 tiers to complete the 200-foot tall structure, designed to meet the unique needs of astronauts and their ground support teams.
So we've added lots of features to this tower that you would not normally have on a normal everyday integration building.
The tiers will be stacked at the launch pad between Atlas V liftoffs and outfitted with wiring, elevators, and emergency evacuation systems before crews begin launching from the pad to the International Space Station.
So Chris Ferguson is the Director of Crew and Mission Systems from the Boeing Commercial Crew Program. In this role, he has comprehensive oversight for crew interface in the design of the CST-100. He's also a former shuttle astronaut, flying on 3 space shuttle missions. He piloted STS-115 and commanded both STS-126 and the final space shuttle mission, STS-135, logging more than 40 days in space. Can you tell us a little bit more about Boeing built both the International Docking Adapter and you're working on the CST-100 and clearly out at the launch pad?
Absolutely. So it's been an exciting time. You've seen some in the video about some of the hardware changes that have been occurring around the Kennedy Space Center. Of course, that was our crew access tower. Launch Complex 41, where we'll launch off of on an Atlas V, rolls out very shortly before the actual launch, and there's no facility there to get the crew up and into the vehicle. So our access tower, as you see, is beginning to take shape. It'll begin construction here. You see the segments taking shape offsite, but it will begin to be segmentedly built here in September of this year, and it'll be finished in March of next year. So a new 20-story complex, which will change the horizon here at KSC, which is always good because every time we see something poke up into the horizon, we know that exciting things are happening. So again, just one of the more visible segments of what is happening with the Boeing spacecraft. Let's talk programmatically for just a second. We've had a very good year. We've completed a couple of the major milestones that have enabled us to receive funding for what we call PCM-1, or Post-Certification Mission 1. This is the very first servicing flight to the International Space Station, scheduled for late in 2017, December of 2017. And in order to do that, we had to complete some changes, some late arrivals for our critical design review, and that was done earlier this year. And then we completed our what we call certification baseline review, which essentially is our roadmap to what it's going to take to become certified to carry American astronauts and foreign astronauts up to the International Space Station aboard our craft. So with that, we received, like I said, an authority to proceed for post-certification mission number 1, which is very exciting. And like Lisa was saying earlier, these missions are scheduled to occur 2 per year. So you'll see a request for proposal for certification mission number 2 coming out later this year, and of course SpaceX and Boeing will both compete for that as well. So it's a very exciting time. I want to take an opportunity to answer a question I heard earlier about, hey, what is it with the Boeing and SpaceX vehicle? What do they have strengths, weaknesses? Is this ultimately going to become a competition? And I think the best way to answer that is just in terms of redundancy. We all learned a very valuable lesson back when we lost Columbia in early 2000. That we had a single string path to the International Space Station at that point, and fortunately, we had our Russian partners that enabled us to keep the space station alive and well and crewed. We look upon redundancy as an essential component to success long term in space. So having redundancy within our own shores is a fantastic thing, and it provides flexibility to both NASA, it provides flexibility to our human spaceflight program, and I think ultimately it turns out to be a very good thing it's a win-win for everybody. So I don't think this is ultimately a competition, and I think you'll see two partners going forward in collaboration and servicing the space station with the idea that always one will be ready. What else can we talk about? Let's talk about the spacecraft itself. We just not far away from here, of course, most of you may know that we're building the vehicle here at the Kennedy Space Center, our factory in essence, over in the old Orbiter Processing Building number 3, OPF number 3, which was a complex that had the orbiter facility and the what we call the engine shop for the Space Shuttle main engine. Boeing, in collaboration with Space Florida, have taken that facility over. We've put some pretty dramatic improvements in the infrastructure, and now we have what we call our lower dome and our upper dome, the two parts, the infantile parts of our vehicle over there for our structural test article that are taking shape. We're eventually going to move our office spaces over there, and then in the larger, what we call the high bay, where the orbiter was, there's some infrastructure changes going on in there, new facilities, new floor, and we're actually framed out right now what we call our ante-room, where we'll do some of our hypergolic work. So it's just so interesting, and you see it not just on the horizon in the form of launch towers, but you see a lot of other infrastructure changes going on at the Kennedy Space Center. And as we come up on the 4th anniversary of the very last space shuttle flight, I think it's very welcome news to the folks here who have been integral to the space program since the early 60s. So we're very excited about all that, and it's just a thrill for me to be a part of it and to see us all go forward. And I, too, have to congratulate Heidi and John back there. Some great words. And what I really like is they're clearly thinking about the future. Space station is a resource we have in low Earth orbit right now, but we all know it's not going to last forever, that we must be thinking beyond that. And clearly the thinking beyond that is taking men and women from this planet beyond low Earth orbit to someplace else, whether it's Mars or an asteroid, and sustaining astronauts for a long period of time. And clearly we have a young man and a young woman, along with their team from Golden, Colorado, to guide us that way. And I'll tell you what, I wasn't doing what you're doing in 8th grade. I was doing something else. I really have to take my hats off to you. The world is in very good hands. Compliments of your team. Thanks.
And what is that sitting next to you?
Oh, I'm sorry. So the IDA, the docking adapter, the PMAs, the mating adapters that are up on the International Space Station are going on about 15, 20 years old right now. So this will actually, one half of it will mate to the existing PMAs that are up there, and the other half will form a new standard for spacecraft that dock to the space station. It extends the length of the docking port by about 30 inches, and as we'll all see tomorrow, one of them will go up to mate to PMA2, and one will go up, I believe, later this year to mate onto to the PMA that'll go on node to the zenith, as Bill had said, to form a new threshold to the space station through which every astronaut that will go back and forth from the American segment will pass. So it's an exciting time for us. Of course, this is Boeing built, and was manufactured at our facility out in Houston at the Product Support Center, and we're thrilled to be a part of the mission and looking forward to see another piece of Boeing hardware become a permanent fixture on the ISS.
Great. Sounds like we should take some questions. Ken?
Ken Kramer for Universe Today and Northeast Astronomy Forum. Chris, can you talk a little bit about when you'll actually be building the first vehicle, I guess, and you're building the structural test article now. Talk a little bit about that. And more importantly, when do you start building the first one? Thank you.
I'll tell you, Ken, it's a very aggressive construction program. As you mentioned, the structural test article is our first. When that's complete, that will go out to a Boeing facility in Huntington Beach, and there we'll stretch it, we'll pressurize it, we'll irradiate it, we'll do all those things you do with a structural test article. In a few short months, we're going to begin construction on what we call our qual test vehicle. This will be very much flight-like. As a matter of fact, we'll probably turn this around and actually make this a flight vehicle one day. But that will have all of the subsystems, the environmental system, the electrical system, the batteries, all the parts that it takes to make it an actual habitable spacecraft. That will also spend some time at various test facilities throughout the United States. And all the while these vehicles are in construction, we'll begin to build the very first flight article, which is the crewed flight test vehicle. And that'll come probably early next year. It will be done. Actually, we just changed our schedule to get some synergies from the various tests and line them up in a better position. That'll be done in time to support the crew flight test in December. Well, the orbital flight test is actually first, and that's scheduled for July. And we're building the vehicle specifically to support that. So the OFT spacecraft will not do any testing beforehand, but it'll be ready to go in July.
And we'll take James.
Sure, James Dane, Florida today. Chris, in the vein of the partnership between you and SpaceX, just this is obviously kind of an interesting mission in that they're carrying up the adapter you built, and neither of you can get there, I guess, without that hardware in place. So I just wonder if you could maybe touch on sort of the unique aspect of that collaboration on this flight.
Well, Hans, you better take good care of that docking adapter, because we are both counting on it. But it's interesting and ironic, I think, how that obviously both Boeing, SpaceX, Sierra Nevada, a lot of competitors began the commercial crew venture back a few years ago. Of course, Boeing and SpaceX were selected for final contracts to deliver material and astronauts, and I just think this is a great element of the partnership that we have going forward. I think later this year we'll see the second docking adapter go up, and clearly we are all in this together. It's a partnership with the Commercial Crew Program and with the various vendors, and we're eagerly seeking to reclaim the business of delivering crew and cargo back to the space station on U.S. soil.
Great.
Jim Siegel, I'm with the Celebration News and Spaceflight Insider. You've kind of touched upon a collaborative relationship with the other companies who are building vehicles. I guess there's 4 of them all together. So beyond working together on the docking adapter and berthing, I'm interested in whether there is any other kind of collaboration that's done among the various companies, or are you kind of like strictly secret, don't talk to each other, lock up everything at night, that kind of thing?
Well, we don't collaborate directly with each other. We have a boss here. We report to our main customer, Lisa, in the Commercial Crew Program, and we count on them and their team to ensure that if there's synergies that can be applied across the various competitors, that they apply them. So again, we don't work directly with one another, but we work through Lisa and her team, and we like to think that collaboratively we're bringing together a partnership that works to the best interest of ISS. But we do still lock the door in the evening.
I think we have a question in the back over here.
What is it?
Wait for the microphone.
Hi, Chris Kerr with the NASA Social Group there. What does it actually mean for the United States to get back into delivering their own astronauts into space, and what are the advantages? What's next with that?
That's interesting. If you're asking us, it's huge. It's our whole life and job, right? I mean, that's what we're doing. That's the whole purpose of our mission. For the country, it means really going back to kind of our roots. We've been doing this for decades and decades. We've had partnerships with companies, like Boeing and now SpaceX and some new players. It's just, it's really inspirational. I think it's a matter of national pride. Not to say that we don't have great partnerships with our Russian counterparts and all, but and Chris talked a little bit about this flexibility for the agency, and space is a growing industry in its own right, with or without the NASA role and the human element. For us, it's all, it's about that. But we're hoping with this commercial vehicle, and they're able to use their vehicles for missions, that are not just strictly NASA missions. There'll be people like John and Heidi's work going up, and, it'll just be between the commercial partners and whatever future holds for space experiments and stuff. We're just kind of in the transition stage for us.
If I may, Chris, that's a great question, and Lisa touched on it. Of course, NASA is our prime customer. That's who we're going to serve. We're going to take astronauts up to the International Space Station, but perhaps there's other business opportunities here. There's Bigelow Aerospace is working on inflatable modules, that one of which you'll see go up to the International Space Station soon here. But there will be, hopefully, a destination in low Earth orbit that replaces the International Space Station someday. It's likely not to be a U.S. government project, but a private company who pulls it together. And that company that pulls together that destination in low Earth orbit is going to need transportation back and forth. So what you see is the transition, perhaps, to space of what the aviation industry went through 100 years ago. We have this great capability to do things, and what do? We deliver cargo with it, right? Like we delivered the mail initially, and then as the industry matured, we began flying passengers around. So fast forward 100 years, well, we're delivering commercial cargo to space now, and pretty soon we're going to be delivering U.S. paying astronauts on a commercial vehicle. So it's very interesting, very compelling time to think about where the business might lead.
I think we have a few questions from social media.
Yeah, Explorer is asking, this is probably best for Lisa, what is the time constraints for space station reconfiguration for commercial crew?
So the time constraints for reconfiguring the station?
Yeah.
Well, I don't know the exact schedule, but as Chris, when we were talking about the schedule that we're on to get our vehicles and the CST-100 and the Crew Dragon to station is very aggressive. So what we do on the program side, and we're talking about partnerships that we have with our industry partners, we have a pretty strong tie and relationship with the ISS program, obviously. So that's kind of one of the intermediary kind of roles that we play as a program, is to understand our provider schedule, understand station schedule, and how we make sure what's needed to be done on station links up and is ready to go for our providers as well.
And I think
and it's different for each one.
I think what Mike Suffredini said yesterday was that we're on track to finish the reconfiguration work, the primary reconfiguration work, by the end of this calendar year.
Yeah.
And another question, this is Kurt, and he's asking, this is for Chris, does Boeing have any plans to christen the individual CST-100 craft with a name?
Yes, we do, and I think you'll see that very soon.
I think there's a question in the back.
That's okay. Hi, Erin Sharoni here with NASA Social. As somebody who's been in space and someone who actually both of you work very hard to keep putting people into space, what's the, I guess if there is one single biggest current hurdle that you see with regard to getting humans into deeper space and keeping them there for longer periods of time?
Yeah, so this is kind of, I was talking earlier about the stepping stones, so it really goes back to, our predecessors, the Apollo, and then shuttle, and now we have Commercial Crew, and we kind of work and we work and learn and grow, and we kind of build off of the previous successes and sometimes failures. You talked about failures in the past, and so we kind of are building on that. And it's a little bit like when you travel or you're planning a trip, even for you, and you're just going around the block to a grocery store or something. You can get there with your bike or car or walking, and then it gets more complicated as you go further, like around the world kind of trips. So the whole build up and of the capability, and the biggest human element of it is sometimes it's maybe not as obvious, but sometimes a psychological kind of element to, you know, having humans physically be able to sustain that kind of environment long term. The effects of radiation is kind of a technical issue that we have. And then also, I think there's a lot of psychological, it's a long trip and, you know, a lot of alone and, you know, focus and have a lot of work to do. So it's kind of a combination. The human element definitely adds to the difficulties.
You know, our horizon is really low Earth orbit. And that's where we're focused on. And if our biggest hurdle, you know, this is a commercial program. You know, NASA formally certified itself when it built Spacecraft. You know, we are working very closely with Lisa's team, but we have a very long checklist that we have to go through before we consider, or our customer considers us certified to fly humans. That's a big deal. So checking off all those blocks as we get to the end of the program and getting Lisa and her team's buy-in that it's good enough to fly humans. You know, if I had to say what our big hurdle will be, it's getting through all those check blocks.
And I guess I should have mentioned too that part of, you know, the reason and the reason we have the commercial crew program is to allow commercial industry to take over that role to low Earth orbit that we have been doing and doing well for many decades, and allow NASA's expertise to focus on more of those long-term challenges to go to deep space. And that's really the SLS kind of PCV, the Orion program. That's what they're really focused on. But this is really connected to that being able to happen.
Great. Next question.
Hi, I'm Elizabeth from Science World in Vancouver at Science World CA and NASA Social. I'm curious about, since the shuttle program ended, what are some of the specific or particular benefits of having to work so closely with the Russian space program that you found?
Well, you know, we've had a good relationship with the international partners, and Russia is one of them. But the space station itself is a testament to all the partnership internationally. So not just the Russians, but the Japanese and ESA. And so it's the broader international community. With the Russians, I mean, I think we've always had a good relationship with them. They realize that we're more dependent on them, you know. There's really no major concerns. It's just a matter of us having the capability and the flexibility as an agency to be able to have a backup in the event that we need it, or just the added capability, period, you know, increase. You're asking if they meaning the Russians have had to add.
Yeah, as a result of the extra.
No, we just have it. We've had, you know, I don't think they've had to add anything like to their capability, if that's what you're asking. The main thing is we just have to, as an agency, buy the missions from them. You know, it takes a lot. There's a lead time, and we have to manifest our crew and our missions pretty well ahead of time. And so it's probably put more emphasis on that partnership and that contractual relationship, I guess I would say. Yeah.
Another question here.
Hi, Casey Ayers with NASA Social. A follow-up on the difference in philosophies between the Boeing and the SpaceX approaches. On the road to human certification, SpaceX has been perhaps more publicly visible so far, things like the abort test a few months ago and so on. And I think that the CST-100 timeline seems to put more of those more publicly visible steps near the end. Is that more a matter of the practicalities of, you know, they're starting from kind of the Dragon and Falcon 9 kind of established point, you're building something from scratch, or is there a difference in philosophy that's behind kind of the difference in how you slate that checklist getting checked off?
Of course, I can't speak to SpaceX's philosophy, but I'll speculate. You know, there's philosophies that say build a little, test a little, fly a little. There's philosophies that say, hey, you know, I have the capability. I've been doing this for several years. I'm going to build. It's going to fly. It's going to work because I'm going to certify it, and I have the engineering tools that when I launch that product for the first time, I just know it's going to work. So I go back to Boeing's commercial aircraft division, right? When the 787 came out, nobody wonders, is it going to fly? Of course it's going to fly. We have tremendous tools. We know how these things work. We know their intricacies at this point. So I think it is just a subtle philosophical difference on development. When you see all these test points come together here in late 2016 and going into 2017, of course, we have utmost confidence that we're just going to knock these off, and the test point itself is just academic. So I believe there is a little bit of a philosophical difference, but there's no less rigor applied. And when you see the test points begin to come off, like I said, they're going to come off in pretty quick succession.
Thank you.
Val, did you have a question?
Hi, Val Phillips, Zero G News. With the potential problem with the budget, how is that going to impact potentially with the seats up to ISS? Are you going to have problems in respect that you might have to go back to the Soviets for more seats? Sorry, the Russians.
Yeah, so we'll have to, assess what we can do and the timing and how that the budget impact really impacts our schedule, obviously. And if, if we don't have the capability ready in 2017, we have already purchased missions from the Russians up until, I think the last one is in 17. But we periodically look at what we need to do looking forward and when the next procurement, I guess, or the next order of a mission from Russia would be. And at that time, we'll just keep looking and see where we are and when that decision needs to be made and whether we are ready with the commercial industry or if we need to continue buying another mission from them. So that's just something we'll look as we go forward.
James has another question.
Thanks again, James, Dean, Florida Today. And just, I guess, setting aside the budget uncertainty that will remain uncertain for a while, you've been referring to having a very aggressive schedules. And on the other hand, you have, milestones mapped out that you're confident, will test well once you get to that point. And I'm just wondering if you can kind of characterize the confidence in assume that you have the budget you need in making that late 17 timeline. Is that an aggressive, everything has to work perfectly schedule, or how much margin do you have in there at this point? Yeah.
There's some, and we are trying to make more. Right now we have some critical path elements that we're trying to relieve. In other words, test a little bit earlier on perhaps a different platform to give us some additional margin. So, by no means is our schedule completely cemented yet. There are dials that we can turn to try to alleviate risk, bring things to the left to give us some latitude. It's a success-oriented schedule. There's no question about it. But we're very confident when we get there, we're going to have we're going to be successful. And if not, we'll fix it. We won't fly until we're ready, until we're safe.
Chris, you said or talked earlier about redundancy with the Russians in the past and everything, and having redundant vehicles. Gary from Twitter is asking, will U.S. astronauts still launch on Russian rockets at times, and Russian astronauts launch on U.S. rockets?
I think it's a question more for Lisa.
Yeah, so I think the plan right now is, to have an interchangeable kind of, we would continue having maybe a Russian crew on the commercial side and vice versa. That's still an option.
Okay, great. Thank you very much for your time, Chris. Thank you for joining us. We'll now watch a short video about the SpaceX pad abort test that happened recently, and then Hans Königsmann will talk to us about the progress SpaceX is making. So joining us now from SpaceX is Hans Königsmann, the Vice President of Mission Assurance.
Good afternoon. Should I just start?
Go ahead.
All right, good. I mean, you just saw the paddleboard video. I'm not sure we should show it again later, or is that? It's a perfect intro, actually. I did wanted to comment over it. What you saw is basically a couple seconds of full thrust of the Crew Dragon. Yeah, here we go. It's looking. This is the same launch pad that Falcon 9 at Slick 40 uses. Same border system. Here we go. A couple seconds full thrust, and this is really fast in a hurry. This is shut down there, and then when you see it from the outside, there's a trunk on the Dragon that keeps it a little bit further up, and it's also for cargo. Here we go. Here goes the trunk. There's a short view where you see the VIB on this video. It's really very beautiful. And then comes the two drogue chutes, and then the three mains. It looks a little bit like a lot of motion there, but it just orients the capsule in the right direction and makes sure that the astronaut land in the water in the right position. So this whole system, that test happened not too long ago. It takes a while for it to come down and to land safely in the water. Crew Dragon, one of the key features is the paddleboard system. It's integrated in it. It uses its. When you look at the Dragon, there's 8 Super Dracos, as we call them, in double packs around it, and they use the same propellant as the on-orbit thruster. And the idea is basically, why not use that propellant either for your paddleboard, or when everything works well, then you have more performance in orbit. And since it is integrated, it's a great way to test it. In our opinion, it's a really safe system. And it worked perfectly on this case. Really happy with that particular test and that particular start here. All right, going back to Crew Dragon, Falcon 9. I just want to point out that both Crew Dragon and Falcon 9 have been designed with astronauts in mind from the get-go. When we started SpaceX, I want to say 13 and a couple of years ago, manned spaceflight was always on the table. It was always something that we considered. It was always something that we based design decisions on, and it is something that obviously plays in your daily work when you ask, so is this safe for humans? Can we fly astronauts with that? That has an enormous impact on the way you design things and on the way you lay something out, on the way you build redundancy, on the way you consider fault tolerance. So both Falcon 9, and I got to point out, Falcon 9 and Crew Dragon are basically designed under the same roof, the same company. In many cases, same people. I work on both systems. So there's a lot of crossover in terms of technology, in terms of experience, and in terms of, and also really important lessons learned. Yeah. So both elements, rocket and the capsule, are designed for maximum safety, maximum reliability when it comes to the human space flight. So that's one part. The other part, of course, is since we use the Falcon 9 on several other payloads, we fly satellites with it, and obviously we're flying the Cargo Dragon right now. That gives us a lot of opportunity to actually learn Falcon 9, see where we can improve things, how we can make it safer, how we can make it more innovative, and obviously that plays into reusability at the same time. How can you make this vehicle cheaper to some extent? How can we make a Dragon more reusable? All those things work when you have the opportunity that we have at NASA supplying the ISS. We're really grateful for that opportunity, and it's just a unique. I'm just really happy to be here. Okay. All right. So that's about Crew Dragon and Falcon 9. The work on Crew Dragon itself is going great. After paddleboard, there's a couple other milestones that happened this year. We're working on and an avionics test bed. Doesn't sound quite as exciting as the paddleboard, but it's a really, really important tool. That's how you test your entire vehicle. You can basically fly the vehicle on the ground. You can sit there, flip the switches, or the touch screens, or whatever we're using. You can test the algorithms. You can test everything, the batteries. Very, very important to get this right before you start putting it into the capsule itself and then do the next test. We work on structural model. We do work on a propulsion module test coming up here. Let's see what else. We had we're also working on the launch site. Not to forget LC-39. This is really incredible. I would not have thought that 2 years ago that we one day would just walk on the same ground where Apollo and the shuttle launch. That's incredible for us. So we're working on that path and getting it ready for the upcoming flights. There's a launch operation readiness review coming up here later this year. So there's a whole bunch of activities that are related to Crew Dragon. By the end of the year, there's a big design review, final freeze and design with all the lessons learned that we learned along the way, whether it's paddleboard or the avionics test bed rolled up into this one test. And then a little bit. The one thing I really like on the internet, on the docking adapter here, it's a really perfect crossover right now. It sits in the vehicle that's right now on the pad a couple miles from here, and it's the key stepping stone for us. If you put this on the station, that is the part that Crew Dragon is designed to actually attach, and so I think it's a really really important and significant part of hardware that we bring up, and I'm also really thrilled about bringing real, not just food and clothes and things up, but also science experiments, worms. We will treat them very well, and and then bigger science experiment like cameras or whatever, and then actually this particular piece sitting on the outside in the trunk and Dragon will get extracted by the arm and put somewhere, and then from what I understand from Mike Staffordini, a very complicated way of flipping notes around will happen before this is ready for us then on the first Crew Dragon demo flight. That's pretty much what I have from status Crew Dragon at this point in time.
Great, so we'll take some questions. Looks like James has a question. Remember to raise your hand, wait for the microphone, and if you want to send a question using Twitter, use the hashtag AskNASA.
James, Dean, Florida today. Hans, what's the timing now for the in-flight abort?
Yeah, so we looked at the paddleboard. We're still looking at the data there, and it's basically that was the first flight test of the Crew Dragon. We're going back and are considering where the in-flight abort fits next, and what is the best place, what's the best value at this point in time on the in-flight abort related to what we learned on the paddleboard on the overall schedule. So I can only say it's right now in flux. There's going to be a better announcement than that shortly.
Okay, Ken.
Ken Kramer, Universe Today and Northeast Astronomy Forum for Hans. Two questions. One, same what I asked Chris Ferguson. When will you have the first flight vehicle ready? And the second is when are you going to pick the astronauts or the team of the astronauts that will actually fly? Thank you.
Let me start with the question number 2. So in our case, the astronauts are picked by NASA. We decided it's the best for our part of the program to have NASA make that decision and help train the astronauts, and so that is not something that I know at this point in time.
Yeah, we have not decided on the crew yet. We're talking. We have conversations on that, but we have not selected a crew yet. I don't know, shortly, soon. Soon. We'll have to, pretty soon. You know, it's really a matter of backing up from the training that's required and knowing when the right time is to make sure that they have a crew, you know, to get through the training period that we'll have.
And then regarding the demo flights, end of 16, early 17 is the time frame right now.
When will the vehicle be ready, though? When are you going to start building it and finish
So
building it?
there's going to be several vehicles that we build. There's going to be qual vehicles and then the first flight vehicle. It's going to be ready just to meet that time. Basically, I don't know the exact when we have the vehicle here. It's going to be ready in time for that end of 16 first flight. And you're probably referring to the Crew Dragon, not the Falcon. Yeah, okay. Because Falcons roll off the factory right now at a interesting pace.
Okay, thank you.
Other questions? Social media? Have we gotten anything on Ask NASA? No. All right. Well, if there are no other questions, then we will conclude our briefing for today. Thank you so much for joining us as we prepare for the 7th SpaceX Commercial Resupply Services mission to the International Space Station. Launch is scheduled for 10:21 a.m. Eastern Time tomorrow, and our launch coverage will begin at 9 a.m. Please join us then for live coverage of the launch and the mission. You can follow along with all the developments made in the Commercial Crew Program at www.nasa.gov/commercialcrew and all of the preparations for launch at www.nasa.gov/SpaceX.